Here we are at our example 3 from our 4.37 notes. We're asked to factor the following quadratic trinomials with a greatest common factor. Now, when we look at number 9, we see that we have a trinomial here. There are 3 different terms, and we have to ask ourselves, what is the biggest thing that we can pull out of each one? Well, notice how this first term and this second term both have x. Unfortunately, this last term does not. And so as a result, you cannot factor out an x if they don't all have them. But looking at the coefficients, our numbers, we do notice that they are all evenly divisible by 2. And since this is the biggest value for the a value, that unfortunately then is the biggest thing that you can pull out of all 3 of them. So that is our greatest common factor. Now when we pull that 2 out, we would be left with an x squared plus a 9x plus 12. Because again, we're pretty much just pulling out or dividing each of these by 2 essentially. Okay, that's how we get those terms inside. All right. Now, looking at number 10, we have to ask ourselves, can we pull a 6 out? It looks really ambitious at first, especially because the first and second term are both divisible by 6. Unfortunately, we can't do 6. This last guy is not divisible by 6. So then you might try 3. Again, the first 2 are, but the third's not. And so you would try your bigger numbers first, and then kind of work your way down to some of your smaller ones. So in this case, in fact, it's divisible by 2. That's your greatest common factor again. So then you'd have 3x squared minus, dividing this term by 2 would be negative 6x, and then dividing this term by 2 would be 16. So positive 16. As we move on, looking at number 11, well, the first and the third are evenly divisible by 10. And again, we can't pull an x out because this last term does not have an x. But the second term is not evenly divisible by 10. And so you could try some other values. When you look at the value like 10, it doesn't have many factors to it. So the next biggest one, lower than 10, would be 5. And anytime it ends in a 0 or a 5, it is always going to be divisible by 5. So that is our greatest common factor here. And then we have to ask ourselves, what is going to go inside of our trinomial after we pull that 5 out of each term? Well, when we divide 10x squared by 5, we're left with 2x squared. When we divide negative 105x by 5, we're left with negative 21x. And then when we divide the 140, we would be left with, let's see, that should be 22. That would be left with, my mind keeps going to 150, so that would be 28. Positive 28. Now, when we look at number 12, looks like 4 might be our first go-to, but then we notice that they're all evenly divisible by 8. And as a result, we would factor out an 8. Now, here's the thing. When your a term, in other words, when it's that coefficient right in front of your x squared term, when that is negative, our goal is always to make this kind of a value in front of the x squared positive. You really want to stress that and make that positive. So to do that, what we would do is actually not just factor out an 8, because they all share the number 8, but we would actually factor out a negative 8 from all 3 terms, okay? And again, because we really do want our a value for the x squared, this guy, to be a positive value when you pull out that factor. And so that number would have to be a regular 8x squared to give you that original negative 64x squared. Factoring a negative 8 out of negative 8x, we would be left then with a positive 1x. You don't need the 1, but you can have it there. And then if you pull a negative 8 out of positive 24, we would have negative 3 there. So that would be our factored GCF, factoring using the GCF. Again, though, that is example 3 from our 4.3 set of notes.